Very common mistake that I make. And I'm just going to double check and make sure that it is recording. Yep, it is recording, and according to this, it's recording from the correct microphone, because otherwise this would be flat and not do anything. And you can see how loud that door is. It's like boom, peaks all the way. All right. Okay, so we'll go ahead and go with this slide, because in this class, it is not even an option to use Windows to do your homework assignment. So you have to run Linux, but most people, I'm assuming in this class also, are not running Linux natively. If you are, you still have to make sure that your code, or you can at least write 32-bit instructions. There are ways to do it. Some of my previous students have figured out what switches to supply to the assembler and the linker to make it work. But the instruction that I give, are for 32-bit platforms. So the best way, the easiest way to do it is just to run a virtual machine in 32-bit. Then you don't have to worry about a single thing. Okay. So the last part of this, okay, this is the only part that you guys need to know if you want to use a portable installation of the virtual machine. This is a link to a QEMU-based Linux virtual machine, and it is self-contained and portable. What that means is this is a zip file. You just have to unzip it to a folder, either on a thumb drive, or you can unzip it onto an external hard drive, something that is portable. Okay? And then you can walk up to a Windows machine, plug in your thumb drive, double-click on a batch file, and then the virtual machine starts. Okay, and I cannot think of anything that is easier. I suppose I can make it auto run. You plug in your thumb drive and it runs automatically. But that's it. I mean, that's how you use this particular zip file. I can show you a little bit, what it looks like, when you run it from Linux. People who use Linux can also use this. I have a little shell bash, shell script file that you can also use, to start up the virtual machine. But that's assuming you have QEMU already installed in your distribution. So it's pretty easy to use. So what I'll do is I'll just kind of show you, how to do it. I'm going to start from scratch. So the folder that is already unzipped, I'm going to remove that. And instead, what I'll do is I will unzip this zip file and kind of show you, how to do it, what kind of files will be unzipped into, and stuff like that. So in Linux, I just use a command line, unzip command to unzip the folder, unzip the zip file. In Windows, after you download it, you can open it directly from the Windows File Explorer, and you can extract all the files to a folder and put it onto a thumb drive. So I'm just going to unzip it first. It includes the 32-bit of QEMU for Windows, as well as the 64-bit version of QEMU for Windows. So there's nothing else you have to install. Just unzip this, and double-click on the batch file, and it starts. This is the big file. Debian.qcow2 is a single file that is serving as the hard disk drive from the perspective of the virtual machine. And once it is decompressed, I think it's about 1.6 gigabytes, but that's including the entire installation of Linux and also the tools that you will need for this class. So I don't think it's too shabby. I mean, it's not too bloated. I suppose someone can make it really small, like 300 megabytes or so, but it's not too bad. All right, so once it is decompressed, you can see that I have a new folder called Linux here. So the next thing is to change to the folder here to show you what files you will see from the top level of that folder. I will explain these files from your perspective. For the most part, you just have to either double-click Start 32 or Start 64. The extension .bat is usually hidden when you look at a file from the File Explorer perspective in Windows. So all you will see will be just a little icon for Start 32 and an icon for Start 64. If you have a 64-bit installation of Windows, which is probably more common than the 32-bit these days, you just double click start 64, it should start up the virtual machine. If you have a 32-bit installation, then you just double click start 32. Are there any questions about how to start this? Nope. Okay. If you have Linux, like I do, you can just double click, or on the command line start this particular shell script, which is just start.sh. It has all the switches put in already for port forwarding and all kinds of stuff like that. So you just have to start the script file. If you want to change the script, in the future, that's fine too. It's just a little text file. When you use Windows, I also supply all the tools that you will need in order to do your homework assignment. PuTTY is included, which means this will allow you to open an SSH terminal to the virtual machine. Without PuTTY, you are limited to only one console with this virtual machine, which is kind of difficult to use because you have to use the same window for editing, for assembling, for running the program, for debugging and stuff like that, which is not convenient. With PuTTY, you can open as many terminals as you want into the virtual machine. So that makes things a lot easier because now you can have one terminal just to look at man pages, another terminal just to edit the file, and then yet another one for the debug session. When you're done with your homework assignment, you have to turn in like a zip file for your files, and that's what WinSCP is for. WinSCP is, oh by the way, SCP stands for secure copy, but it's not just copying a file from one location on the hard drive to another location on the same hard drive. SCP is based on SSH or Secure Shell. It is a remote copy utility. So you can use that to copy files from one computer to another computer. In this case, you can copy files from inside the virtual machine to the hosting environment outside of the virtual machine. So that's how you can transfer files between the hosting environment and also the virtual machine itself. So any questions at this point? But let's go ahead and give it a try. So I'm going to start up the virtual machine. In Linux, I have to use start.sh to start it up. So just press the enter key, and this is the virtual machine. I'm going to maximize it so that you guys can get a better view at it. Here we go. It runs pretty fast here because I'm able to use KVM, because I'm using Linux. It's an accelerator. It's making use of the hardware acceleration feature of the i7, i5 processors. When you use it in Windows, it'll run a little bit slower. Okay, so it might take maybe 30 seconds, 45 seconds or so to start up the virtual machine. But since most of your homework assignment will take about half an hour, 45 minutes to do, the overhead of starting up the virtual machine should not be a big issue. Once you start it up, there are two accounts already created in the virtual machine that I'm distributing here. The first account is a regular user account, and the username is just user, okay? And the password is also just user. For this class, this account is not going to be very useful because I want you guys to set up your own account with your own name. Okay, so the user account, you can use it. If you want to test something, I would use it. But for homework purposes, you have to set up your own account using your last name as the name of the user. Okay, I'll give you the instructions later. Okay, so this is one way to log in. Or one account that you can log in. I'm going to log out of this one. The other account is more important. It's called a root account. A root account in Linux or Unix is the administrator account. In other words, this is the account to do all kinds of system administration. If you want to install new packages, if you want to deinstall packages, if you want to add a user, delete a user, you have to log in as root. Okay. For those of you who already know Linux/Unix type of thing, I do not have a sudoer set up, with this particular distribution. You are more than welcome to set up sudoer if you want to. Okay. The default password of the root account is beer, just lowercase b-e-e-r, root beer. I try to make it easy to remember, so root beer is the password of the root account. And once you log in as root, then you can start, like using the command called add user. You can add a user based on your last name, and then you can use that for doing homework assignments for this class. Are there any questions about how to work with a how to work in the Linux environment. The individual commands that you will need to do your homework assignment, there is a homework assignment just for that. Okay, and I will be doing that pretty much on a daily basis. Every class I'm going to do, I'm going to write some sample programs, go through the whole process. So you will get the exposure of what commands to use, how to remove a file, how to create a file, how to create a folder, and so on. Yep.
Is this virtual machine persistent?
Yes, it is. It is actually an quote unquote installed Linux. It's an actual Linux installation. So whatever changes you make is permanent, in that virtual machine. Since it is QEMU, you can also switch to the console mode, and you can take a snapshot if you want to. When it is time to shut down the virtual machine because you're done with your homework and stuff like that, there are 3 ways to shut it down, okay? And I'll call these 3 methods: the good, the bad, and the ugly. So we'll start with the bad, okay? The one that you're not supposed to do. Don't turn off the host machine just by unplugging it. Okay? Because if you did that, it is possible that your virtual machine can get into a unrecoverable state. And the reason why is because the virtual machine uses a file system that is fairly robust. It's called extension 3 or extension 4. I think this one uses extension 4. It's really robust, okay? It can survive a lot of bad things happening to it. But because it's a virtual machine, it also means that even though Linux is convinced that it has written all of the important stuff onto the hard drive, it is not the actual hard drive. It is just a file from the perspective of Windows. And if Windows is doing some kind of caching and decide, I don't have to write this stuff back to the hard drive just yet, okay, I'm gonna wait. And then you unplug the computer, that content is not going to be written back onto the hard drive. Even though from the perspective of Linux, it has already been written back to the hard drive, it's not onto the actual hard drive. And that can cause major issues. Okay, so never unplug your PC, to turn it off when you have a virtual machine running like this. Okay, so that's the bad. The ugly, which is something that you can do, probably not cause any problems in general, is to click the close button up here. Okay, I know you guys are running Windows and not Linux, but when QEMU run in Windows, it still has a little close button. That is equivalent of unplugging a Linux box, just unplug it out of the wall. Okay, it will probably survive. Okay, it's not the best way to do it because you might still lose like one file or something like that, but you're not going to host the entire file system as a result. Okay, so I will still not do that if I can help with it. But if your Linux box is crashing or it has a kernel panic or something like that, that's the only way to close it down. The best way, the good, is to go into the root account and then type the command called power off. That is the best way, the safest way to shut down a virtual machine is to shut it down properly from inside the virtual machine and not just close the virtual machine from the outside. Okay, so power off is the command, but you can only run it inside, as a root user. So you have to log in as root, in order to run power off. Are there any questions about, how to shut down the virtual machine? Questions? All right, very good. And once you press, once you enter the power off command, it will show you some text, showing you the progress of shutting down, and it will get you back onto the main prompt if you're using Linux. All right. Any questions about this? No questions. All right. So what we'll do, once you know where to get the virtual machine and how to basically start it up and shut it down, we can now, I can unlock, one of the homework assignments. It's just called environment. Okay. So what I'll do is to enable that one. And it's imported this, from the other class, which is not what I wanted to do. So I'm gonna just change that a little bit here. with environment, I'm going to change it to. So I'm going to edit the settings. And I'll explain that too, okay? I'm just going to go through this to make sure it is available to you before I go in to explain, what you have to do to get the homework done. So I'm going to give you guys a week to do it, like 7 days, which is probably a lot more than what you need. You can do it in the lab right after the lecture in room 128. If you have a thumb drive with you, you can just go ahead and download the virtual machine and use it right away to get the homework done. So I will make the due date 1 week from today, and I guess a calendar is easier to use. Today is the 28th of August, so I will make the due date September 4th. There. And I'll make it due right before the class, or right at the beginning of the class, so that will be like 9 a.m. The cutoff date is going to be disabled. Okay, so but late submissions will not be receiving any points, so just keep that in mind. Restrict access, I have to change that because I changed the activity itself. So that's it. Okay. All right, so now we can actually take a look at the homework assignment or the description of the homework assignment itself. The purpose of this homework assignment is to make sure that you have the right kind of environment and to introduce you to basic commands that you will need to know in order to do your homework assignment. There's nothing you need to know about assembly language programming for this particular homework assignment. I give you the code. You just have to punch it in, type it in, and that's it. Okay. So the detail of this is the first step is to create a homework user with the last name as the first part of your username in all lowercase. If your last name is hyphenated or has apostrophes, just remove the hyphen or the apostrophe. Okay, so just make it one long string of lowercase characters, lowercase letters. So in order to add a user, you have to sign in as root first, okay? And the default password of the root account is beer. You have to use the command called add user, and then use your own last name to create the account. Okay, I don't want anyone to use LASTNAME as the name of the account. And then after that, this part is not needed because I have all these packages already installed in the virtual machine. But you can repeat this command if you want to. It just doesn't do anything because it is already, these packages are installed already. And then the rest of the steps do not require administrative access. So that means you can log in as your other user, to do all of these additional steps. So you want to set up a folder in the home directory of the homework user based on your last name. So you have to sign out as root and then sign in using the new account name. That's what this part is about. The second part is to create a folder using the mkdir command. And the folder has to be called assignment 1. And then use the next command to change directory into assignment 1. And then step 2 is to perform the following steps here. Create a program as indicated in the pink area. So when you scroll down the screen, here's the actual code. I suggest that you type it in instead of try to copy and paste it. There are ways to copy and paste it. The problem is sometimes, when this looks like the right code from the HTML perspective, it will give you the wrong code when you paste it into a text file. Particularly symbols like double quotes, and stuff like that, it can be encoded incorrectly when you copy and paste from HTML. So I would just go ahead and type it in. It's not really that bad. To type in a program like this. Okay. So the pink area is what you need to type in as a part of the program, and that's step 3 of it's sub step 3 of step 1 of these steps here. Oh, excuse me, I take it back. It's sub step 1 of step 2 of these particular steps, and the file has to be called asgn1 assignment1.lowercase s. Okay. And then in step 2, you use the assembler, which is kind of like a compiler. except it does not compile from C++ code to object code file. It compiles or assembles from assembly language file, from an assembly language program to the object file. And the command is as-gsteps-o asgn1.o and then asgn1.s. Okay. I try to highlight all the commands in yellow, so that way you can clearly see which part is a command and which part is not. Any questions at this point? Next step, you can use, this one is optional, okay, but ls-l is a really useful command. ls stands for list. It allows you to take a look at the files in the current folder. -l means use the long format, so it doesn't just show you what files are there. It also shows you the size of the file, when it was last modified, and so on. There are additional information it will display. The next step is to do the linking, because once you have the object code file, you still have to link it in order to create the executable. So the ld command is the linker, and you just run it using this particular command here. And then you can use ls to double confirm that the executable is in fact created. If one of these steps gives you like an error message, don't proceed. If the assembler complains there's a syntax error, there won't be any object code file to link. So you got to make sure that you fix a problem before you move on to the next step. And then you will create another text file based on the blue area, at the lower portion of this assignment. The blue portion is exactly just this part here. These are the commands that you will pass to the debugger in order to, check whether your program is working correctly or not. So what you do is to use this to create the second file. The second text file is going to be called debug.gdb. Okay, so right here you will create a new file, and the file name is debug.gdb. And then what you're going to do is to debug the program using GDB. So you'll basically be running the program called ASGN1, but you'll be running it through the debugger, and the output of the debugger is going to be stored in debug.log. Okay. Step 3 is once you have everything done, you want to archive the entire directory. And this is the command to archive the entire directory. You have to make sure that you observe the spaces, because sometimes people miss the spaces between the commands. You also have to observe the casing of the switches. This is an uppercase C, not a lowercase c. And also the punctuations. This is a back quote or back tick. It is the key on top of the tab key on your keyboard. It is not a single quote. And this is the same character. It is a back tick. It is not a single quote. So you got to make sure that you have all of these things done right. Otherwise, the tar command is not going to run correctly. All right. Are there any questions about all of these steps? I would basically run it all through, kind of quickly in the class, so that way you can actually see, how the commands are used and so on. Any questions? No questions so far? All right. So what, in the end, what is created is going to be a file that is called assignment1.tar.gz, and you will have to turn in this tar file onto Moodle, okay, using the Moodle web interface. So I'm going to go through this entire thing as much as I can, to resemble what you will have to do in Linux. Okay, there are a few steps where it is much harder for me to do it here because I don't have WinSCP in Linux to show you that particular tool, but I can at least tell you what file is being transferred. So you still have to learn how to use WinSCP by yourself. How many people have used FileZilla or something like that? Well, it's just like that. I suspect FileZilla can also be used in this case. You can give it a try. Okay, it uses SCP. The protocol is called SCP or SSH. Okay, if FileZilla supports that, you're all good to go. You don't have to use WinSCP. Let me just kind of search right now to see if FileZilla supports it. FileZilla SCP SSH. Programmers cannot spell. looks like it is supported. I'm not 100% sure. Can someone tell me whether it is supported or not? Don't know? Well, WinSCP supports it, so in the worst case, it's just to use WinSCP. All right, so I'm going to go through all of this stuff here, and so you can basically just watch the video and reproduce the steps just one by one, step by step. Okay. So I will start with using the virtual machine. Yes, I am in Linux already. I did not actually have to use the virtual machine, but I want to resemble the steps that most of you will have to do, so that you can see what you'll be seeing when you do this homework assignment. So I'm going to start up my virtual machine just like before. And I will sign in as root with beer as my login, as my password. So I'm going to switch back and forth between the browser and the emulator. Log in as root, and then use add user, to create my account. Okay, so let me switch to QEMU here. Add user is one command, and then I just have to supply my last name as the account name. And what it will do is it will just kind of go through this process here and ask me for a password for this user account. If you're doing this on a virtual machine and the virtual machine is not exposed to anything, it's not really going to be a terrible thing if you use a very common and easy to remember password. Okay, because your virtual machine is usually should not be exposed to the internet at all. Okay, unless you change the switches when you start up the virtual machine, then you can potentially be exposing your virtual machine to the internet. But if you run it the way it was set up, this is completely only accessible from the host environment. So as long as your host environment itself is secure, I don't think anything bad can come to the virtual machine. So I'll just pick something that's really easy here. And the rest you don't have to enter. Like when they ask you about your full name, room number, and stuff like that, you can just press the enter key and just zip through it. All right. So I'm done with the add user command now. I'm going to run the aptitude command, just so that you can see what it looks like when you run it. So aptitude install bin utils make. Oh, okay. It might actually install make because I don't remember installing make here. Yep, make is new, so it's installing that. And that's it. This is also kind of the nice thing of using Debian Linux. When you want to update the operating system, you just have to run two commands: aptitude update, and then a semicolon to separate from the next command, which is aptitude upgrade. And that will bring everything up to date. Okay. All right, so I'm done with these steps over here, and it's time to move on to the other steps. Set up a folder in the home folder or the home directory of the user account that I just created. So that means I have to, we have to log out of the root account and then log back into the account that starts with my last name. All right, so now that I log in, I create a folder using mkdir or make directory. And I think it's supposed to be called assignment 1. And then use cd to change to that folder. So you can see that I typed really fast. It's called auto-completion. When you press the tab key when you're typing the file name, and you press the tab key, if there's only one file matching that beginning of the file and you press the tab key, it will just complete the file name for you. If there are multiple files matching the beginning of, if there are multiple files with the same beginning that matches what you have typed so far, you can double tap and then it will list all the files with the same beginning characters that you have typed. All right, but it is just a shortcut. You can improve the efficiency of using the command line using these little shortcuts. Okay, so now that I'm inside the subfolder called assignment 1, I can finish up the other steps here. Right here, I'm going to create a program as indicated in the pink area. And then I will have to use it to make the file called asgm1.s. Okay. So in this case, I'm just going to go through the trouble of actually typing it in. I like VI, but you don't have to use VI. If you like, Nano, you can use Nano. So I'm going to type it in. There are many shortcuts, to this particular step, so that you don't have to actually copy and paste in the entire thing. So, but I'm going to go through this, and I'll be explaining just a little bit of this program as I type it. So I'm going to make it a little bit larger on this side so that you can at least see some of what is going on here. Okay, so the first line is .global start. .global start is basically telling the assembler there will be a label called _start. Okay, when this program is all done, make sure that label is exported. Okay, so that everybody can see this label. _start is a label that marks the entry point of your entire program. So that has to be known to the linker, because the linker has to mark a certain location as the starting point of your entire program, so that when you run the program, the operating system knows where to start the execution of your program. So that's the significance of _start. .text basically switches to the text section, which is the one section that contains code instead of data. Hello, colon is the definition of a label. .ASCII gives you the ability to create a string, kind of like in C, it creates a string. And then we have .byte10 here, which is a line feed character. Okay. That 10, by the way, is in base 10. Yep.
Can that hello label or that bolded line be on the same line as .text?
No. In assembly language programming, the directives are on a line-by-line basis. So most of the directives, if not all, cannot be combined onto the same line. The definition of a label is one of the exceptions, where you can actually put stuff right after the definition of a label. Like in this case, hello colon, can be followed by something else. Sure. And then hello end is the definition of another label which marks the end of the string that I want to print. _start again to define the actual entry point of your program. The first instruction is no op, which doesn't do anything. And then we have stop here as a label. That's strictly for the debugger purposes. And then we have move L $4, comma, %EAX, which moves a constant of 4 into a register called EAX. Now, all of these concepts will be explained. So if you don't understand what is a register, what is a mnemonic move L, don't worry. All of that stuff will be explained. At this point, it's just a matter of typing in the program, going through the steps to run this program. Int $0x80. So don't miss any punctuations, because if you miss the $, the program will assemble, but it won't do what it's supposed to. So you have to make sure that all the $signs and percents are there properly. And then we have move 1 into EAX, move 0 into EBX, int $0x80. That's the entire program. See, it didn't take too long. I mean, it was maybe about, 2 minutes or so. And then in VI, I use :X to exit the editor and save the file. If you use Nano, it's a little bit different, okay? And I'll just kind of show you what Nano looks like for the same program. So if I use Nano, ASGN1.S, that's what it looks like in Nano. Okay? So you can choose which one you want to use. It's entirely up to you to pick your editor. All right, so now that I have the program typed in, I'm going to go back to these steps here to finish up the assembling. Check that the assembler creates the object code file, do the linking, make sure the linker creates the executable, and then I will copy and paste the debug.gdb content into its own file. All right, so switch back to here. Some of you cannot see what I'm typing here, so let me change font here a little bit. It's still pretty hard to read because it's actually gray and not in a completely white text here. Okay, so let's go ahead and do the rest of the steps. AS is the name of the assembler. G steps -O ASGN1.O ASGN1.S. Okay, I didn't get any errors. LS-L. Now it's showing me 2 files instead of 1. Let me see if I can turn off the light or one more lights. Quite get the contrast. Is that better?
Yeah.
All right. So the next step is to do the linking, which is LD. -O to specify the name of the output, which is the executable, ASGN1. And then I have to specify ASGN1.O as the input, because the linker uses the object code file as the input, and then it creates an executable out of that. All right, do another LS-L. Now I have 3 files with ASGN1 highlighted as kind of like a lime green color. That means it's an executable. This is 1 file that I can actually run. All right, next step, going back to my notes here, or the assignment description, I have to create the debug file, okay, the debug command file, and that one is over here. Create a text file as indicated in the blue area, and call that debug.gdb. Okay, so let's scroll to that portion here, and then create that file. I'm going to move this one a little bit to the right-hand side so I can see both screens at the same time. So I'm going to create debug.gdb, and B stop here is to set up a breakpoint at label stop here. R is to run the program at full speed until it gets to a breakpoint. Once you get to a breakpoint, I want to do a single step, which is what the S command is for. IR is info register. I want to see the content of a register. In fact, in this case, I just want to take a look at the register EAX, and that's why it's IREAX. Single step again, and then look at the content of EBX. Continue execution at full speed is C, and then Q is to quit, to exit from the debugger. So I've just typed in all the commands here. I'm going to save the file and exit from the editor. And then go back to the instruction here. Go all the way back to run this command here. Okay, I'm running GDB to debug the program using the commands that I have typed into debug.gdb. The output of this entire thing is going to be logged into debug.log, which is a file. So I'm going to go back to the virtual machine and do exactly that. So it's GDB ASGN1, redirect, which is the less than symbol, redirect input from debug.gdb, and then redirect the output to debug.log. Press the enter key. It is as if nothing happened because the output is captured in the file, so that's why it is not displayed. So for those of you who are curious, you can actually use the editor to take a look at the log file. So debug.log is kind of like this. This is what you normally would see when the debugger runs, but since I'm redirecting the output, instead of seeing this on screen, it is now captured in a file. So I got everything done at this point as far as all the steps are concerned. The next step is to archive everything. So I'm going to run this command here in on the command line. And the command looks like this. It's tar, T-A-R, CZVF. Okay. Now each one of these letters, has a meaning. C stands for create. Z stands for gzip, which is compression. V is verbose. It will show you what files are getting, compressed and put into the archive file. And then F is to specify, okay, what is the name of the archive file? So the archive file is now specified as tilde, which is the short way of referring to your home folder, and then the actual file name is assignment1.tar.gz. The actual command, or to specify what do we want to include into the tar file, starts with a -C, which is to change directory to the root folder of the entire system first. And then the backtick is to say whatever command is enclosed into the backticks, use the output of that command as a part of this command line. Okay, so it's backtick pwd, which is the print working directory backtick. So it will print the working directory and then use it as a part of the original command, which is the tar command. And then when you press the enter key after this really kind of long and obscure command, it will look like this. Don't worry about the first message. For those of you who can barely read it from way back there, it says tar : removing leading / from member names. That's perfectly normal. Okay, it's a perfectly normal warning message. There's nothing wrong with that particular warning. But you should see a list of the files that are being archived to be included in the archive file. Any questions at this point? Yep.
Did you say on the PWD, is that an apostrophe or is that the thing?
It's a
that's on-
backtick.
Okay.
Yep. So it's surrounded by two backticks. Yep. All right. So now I want to double check that the file is in fact created. So I'm using ls-l tilde, which is the home folder, /assignment1.tar.gz, and that file is now created. This is the timestamp for the file, and the file size is 1,526 bytes. So you can probably imagine that throughout this class, you'll probably use up a few kilobytes, maybe 10, 20 kilobytes for all of your homework assignments. All right, so are there any questions at this point? So I have the file that I need to upload to Moodle already, but it's inside the virtual machine. From the outside the virtual machine, there are no real quick, easy way to access that file. So in Windows, I will have to use WinSCP to transfer assignment1.tar.gz from the virtual machine back to the environment. But since I'm not using Windows, I don't have a version of WinSCP to use. So I'm going to use another approach, which is a command line approach, to do the same thing. Let me see if I can find a FileZilla for Linux. Does anyone know whether FileZilla has a version in Linux? Nobody.
I think so.
You think so? Okay, let's go ahead and see. Because that way I can show you what you guys will see when you use FileZilla for that purpose. It is in the form of a tar.gz, a tar file too. Is it a package in Linux? It is. In fact, it is already installed. Great. Okay, so I can use FileZilla. So if you're in Windows, you can probably do the same thing. But the first thing I want to do is to make sure that it can actually connect to the server. Okay, so I'm going to create a new site here, and the host. Okay, this part you have to make sure that you remember all these steps, but it's getting recorded. The whole thing is getting recorded. The host is going to be localhost, okay, because it is not actually another machine. It is the same machine but running a program pretending to be another PC. So the host is going to be localhost, which is just localhost in one word. If you want to give it a number, it can be 127.0.0.1. That should work across all the different platforms. So 127.0.0.1 is exactly the same thing as localhost. At least, as far as I'm concerned, of all the Windows machines that I have tested, this should work. The port number is also important because the typical port number. Okay, let's see if let's back up a little bit and change the protocol first. The protocol should not be FTP, it's SFTP. SFTP and SCP are based on SSH, so they should both work in this case. The port number is typically 22 for FTP, but the virtual machine does not use port 22. Instead, I think it uses port 2200, so you have to put in 2200 here instead of leaving it blank. Are there any questions about this step here? Okay. And then the login type is not going to be anonymous. It's going to be ask for password. and the username is based on your last name. So in my case, it is AUYEUNG, and the password is what I just specified a little bit earlier. Oh, okay. When you select ask for password, it will interactively ask you for the password when you make a connection. All right. Any questions at this point? Okay. If there are no questions, let me see what else I can do here. Okay. It is called new site. I'm not going to change fuss with that. So I'll just go ahead and click OK, and nothing happens. Site manager. I guess I have to click connect. There we go. So once I press connect, it asks me for the password to log in. That means the connection is made, because if it didn't make the connection, it would not ask me for the password. So the password in this case is that. Click OK. The next question is, it will always ask you, because in case your connection is going through a man-in-the-middle attack, you may not be connecting to the machine that you thought that you were connecting to, and that's why it always asks you to double check the fingerprint of the server that you're connecting to before you go through the connection. In this case, one, it is a local host thing. It's really, there's no concern of a man-in-the-middle attack. So you can just go ahead and click OK, and the connection is made. So now you can see that on the right-hand side, we have the local machine, which is a Linux box already, and then on the right-hand side, we have the virtual machine that we're connecting to. So what we want to do is to copy assignment1.tar.gc, which is this file, to somewhere on your host, in your host environment. So in the host environment, I'm just going to put it into the temp folder. Okay, so I'm going to drag this file into the temp folder, and that's it. So now it is in my temp folder in the host environment. In Windows, you can drag it onto your desktop, you can drag it into your documents folder, you can drag it into your downloads folder. It doesn't matter, as long as you remember where you're dragging to and be able to retrieve it in Windows, that's fine. Are there any questions about this step? No questions? All right. So if there are no questions, I'm really done with FileZilla at this point, so I'm going to close it. And then I will switch back into Moodle. But since I logged in as instructor using Chrome, I'm going to log in as a student in Firefox, just so that I can show you what you have to do in order to turn in or to submit your homework assignment. So I'm going to go into Iceweasel. Guess what? Iceweasel is Firefox. So go to moodle.lostfields.edu. And then log in as a student this time, so I'm not logging in as an instructor. And then cisp310 is already here. Navigate to the homework assignment. So in this case, the homework assignment may not be open. Oh, it is. Okay, so I answered the syllabus acknowledgement already, so I can actually access environment. Click it. And scroll all the way to the bottom, and here you will see a button called Add Submission, which allows you to upload a file. So once again, scroll all the way down, click somewhere here, or you can drag and drop if you want to. And then make sure that you are selecting Upload the file. Click Browse. So now I'm browsing on my computer, not on the remote side. And then the file is called assignment1.tar.gc in my temp folder. Click Upload this file. That's taking a lot longer than I thought it would. this again, do an upload and browse. Select the file, click upload this file. Normally it's done in a few seconds at the most. This is kind of odd. All right, there we go. We are not done yet. You have to click Save Changes. If you do not click Save Changes and exit out of the browser, that file is not turned in. Okay, it is not counted in as turned in. So make sure you click Save Changes and see the next screen before you get out of Moodle and move on to something else. Because you should see the screen here that will confirm that your file is uploaded, because you can click this link and download that file back in again. Now, what if you turn it in already, it's before the due date, and you decided, oh, you know what, I forgot one thing. Okay, I forgot to capture the log file, or I just want to double check something, and you want to upload a new file. But if you want to upload a new file, you have to click Submit, Edit Submission. But you cannot just upload a file because one is uploaded already. So what you would need in that case is to click the file that you have already uploaded, click Delete, and then you can upload again. Okay, so you cannot just upload another file because you can only upload up to one file. If you have already uploaded one file, then you have to delete it first before you upload again. Are there any questions about this process of turning in your homework assignment? Any questions? All right, so that's it. Is everyone feeling kind of comfortable with this particular homework assignment? Yeah. All right, cool. So I'm going to turn on the light again because it's kind of too dark for people to write down on paper. I'm going to turn on two more minutes of light. Once they switch from fluorescent lights to LED, we can have dimmers so that it won't be like just suddenly, and it just blinds everybody in the class, right? All right. So once we have this one out of the way, I'm going to continue to move on and talk about the actual, subject matter for this class. I think last time I kind of showed you guys, bad return already. Okay. How many people went back and took a look at bad return and tried to figure out, why it did all the strange things that it did? No one? Okay, you did. So what was your conclusion? What is your conclusion?
I didn't have one.
Okay, well that's okay because that's good. But I like the fact that you tried, because that's the whole thing. At the end of this semester, I'm hoping that everyone will look back at badreturn.c and know exactly what went wrong with that program, why it behaved the way it did. Okay, that's the objective of this class. All right, so what we'll do is we'll start with, I think we're done with why assembly language programming. To summarize, the objective is not to enable each and every single one of you to become a programmer to do assembly language programming for a living. Okay, out of a class of 30 people, I would say about one or half of a student will be programming in assembly language ever in his or her career. The majority of you will not drop down to assembly language level at all in your entire computer-related career. But the point of this class is to gain enough knowledge. I'm passing the row sheet right now. But the point of this class is to give you an insight of what a C++ program looks like at a low level, so that if your program is misbehaving, like badreturn.c here, then you will have the tool, the knowledge, in order to debug that kind of a problem much more effectively than without taking a class like this. So that's why you want to take assembly language programming and learn what I'm teaching in this class. There are a few choices here for my next topic. So what I'll do is I'm going to pick just the next one, which is binary numbers addition and subtraction. The addition and subtraction are in binary. Okay, I'm not just teaching you how to add and subtract. I'm teaching you how to add and subtract in base 2. All right, so here we go. So we'll start with binary numbers here. I'm not going to read this text here. That's kind of boring. So instead, I will ask how many people already know how to do base conversion from base 10 to base 2 and then base 2 back to base 10. Okay, so I would say that's about maybe 1/3 of the class. How about the rest of this class? In cisp300 or cisc310, I think some classes cover base conversion.
Yeah, that was a long time ago, though.
That was a long time ago. Very good. Okay, so base conversion is easy. It's easy and easy. If I want to give someone change, okay, for a certain amount, okay, I'm going to use the projector for this purpose. So the first thing I want to do is to make sure that we understand what base conversion is about, and the fact that it is very easy to understand is easy. Okay. All right. So let's say you want to give someone change, and the amount is let's say $85.75. Okay. Can you tell me how many bills and coins to give that other person? If I want to use the least number of bills and coins, can you figure out what to do with this amount?
Yeah.
Okay. Okay. Tell me.
10, 4 1/4.
Hmm?
A 50, a 10.
Okay.
A 20.
A 50, and then a
20.
20,
A 10.
a 10,
A 5.
a 5.
3/4.
Okay.
Are you trying to go least possible?
To use the least number, but only using the more common denominations. Okay, because I know you can get a $50, but most people don't have a $50. So a quarter is using 3/4 is good. Okay, so you can do this already, right? How many people needed to do it on a piece of paper? No one. Very good. So you all qualify to become the clerk at a fast food place or something like that. Yeah. Well, trust me, some people cannot do that. They cannot do it, in their mind. They have to use the machine, and the machine, when they punch in something incorrectly, they cannot fix it. They cannot, do all the math in the head. All right. Well, guess what? Base conversion is easier. Yeah. In base conversion, you just have to think about the bill values to be $1, $2, $4, $8, $16, $32, $64, and so on. In other words, the amounts are all of powers of 2. It goes in the opposite side too. So you will have half dollars, quarter dollars, $8, $16, and so on. Am I doing okay so far? So just kind of imagine that you're living now in a different country where they have $1 bills, $2 bills, $4 bills, $8 bills, and so on. And then in terms of coins, they have $half coins, they have $quarter coins, $8 coins, and so on. Is that okay? Can everybody kind of imagine that's the amount of that's the kind of money deal that you're dealing with? So in that case, what will I do with $85.75?
64.
One of the $64, okay? And once you take care of the 64,
The 16.
okay, 116, okay, very good. 1 4, 1 1, $1/2, and 1/4. Very good. All right, but that doesn't look like a base conversion to me. Well, let's think about what is 64. Okay, 64 is 2 to the power of what? Oops. Come on. 6 is correct. Okay. 16 is 2 to the power of 4. and 4 is 2 to the power of 2, and 1 is 2 to the power of 0. Very good. You guys remember your stuff. Okay. What about what about 0.5 is 2 to the power of what? -1, and a quarter is 2 to the power of -2. Yep. Okay. Now, why is that important? Because in base 2, 2 to the power of 6 is represented as 1 followed by 6 zeros. Okay? So this is 1 followed by 6 zeros in base 2. I use the parentheses 2, as a way to indicate this is now a base 2 number and not a base 10 number. In other words, this is not 1 million, it is 1 followed by 6 zeros in base 2. So 2 to the power of 4 is 1 followed by 4 zeros in base 2. 2 to the power of 2, 1 followed by 2 zeros in base 2. What about 2 to the power of 0? How many zeros should I put in on the right hand side?
0.
0, exactly. Okay, so the power tells you how many zeros I have to put on the right hand side of the 1. Okay, so 2 to the power of 0 is 1 with no zeros on its right hand side. Then what are we going to do about the -1?
0, 1.
It becomes fractional, right? So it becomes how many places is, this number is the one after the decimal point. So 2 to the power of -1 is 0.1 in base 2. And then 2 to the power of -2 is 0.01 in base 2. Is that making any sense? I mean, 0.01 is 2, in base 2 is 2 to the power of -2. Well, let's think about base 10 again. I'm just going to do this one on the whiteboard. 0.004 in base 10. What is that? What does that mean? 0.004 in base 10. It's 4 times 0.001, right? The 4 is just how many of those things do we have, but one of those things is 0.001. But what is 0.001? It is 10 to the power of what? -3. So this 1 is 3 places after the decimal point. It works exactly the same way in base 2. Okay, so 2 to the power of -2 is 0.01 in base 2, because it is 2 places after the decimal point. Are we still doing okay so far? All right. So in this case, I don't even have to explain the rules of how to add in base 2, because guess what? They never really trigger any rules of carry, right? So now I can, well, let me see if I can write this vertically. So we have 1 followed by 6 zeros, plus 1 followed by 4 zeros, plus 1 followed by 2 zeros, plus 1, plus 0.1, plus 0.01. All in base 2, right? Do you think, just because we are now dealing with base 2, that this number will be added in a different way? No, because the carry never gets triggered. It's only when carry is triggered that you have to be careful and know which base you're dealing with. All right. So what is the answer? It's 101010.11 in base 2. You have just learned base conversion in any base. If I give you an example of base 7, would you be able to convert a number into base 7? Slower, yes. But the concept is the same, because in that case you have $1 bills, $7 bills, $49 bills, and so on. And then on the other side you have $7th bills, coins, 49th coins, and so on. Okay, but it's the same concept. If you know how to make change, using our current currency system, you are done. You are so an expert in base conversion. And the reason has to do with our currency system has no regularity whatsoever. Think about it, okay? You have learned a far more complex system without even knowing it. And what we're doing here has regularity. It is easy by comparison. Just think about it. A penny, a dime, a nickel, a dime, a quarter. Do you see any common multiplier here? No. 5, 2, 2.5. 4 as a multiplier, and then 5 again. 2, this is the first time 2 happens, by the way, from 5 to 10. And then another 2, another 2.5, another 2. I don't see any regularity in this pattern here. Am I making any sense? Okay, I'm making sense out of something that does not make any sense. Right? If you can deal with something like this, that is a lot easier because it has a pattern. Okay, all of those numbers are powers of 2. If you're dealing with base 3, all of those numbers are powers of 3. If it's base 4, all of those numbers are powers of 4, and so on. So that's why, if you think about it this way, that is actually easier. Base conversion is so much easier than dealing with the currency amounts that we have here. All right? Is everybody feeling kind of more confident with base conversion? All right, very good. So now that base conversion is done, I can actually talk about how to add and subtract in base 2. And that's also easy. Okay? And people keep saying, but Tech, you say everything is easy. But that really is the case. Okay, let's think about base 10 first. Okay? In base 10, what is, I'm just going to give you one quick example here. What is 2 minus 5? Well, most people would say -3, which is a correct answer. But when you're dealing multi-digit subtraction, what is 2 minus 5? 2 minus 5, when you have multi-digit subtraction, is actually 7 with a borrow. Is that making any sense? In other words, when you have 12 minus 5, then 2 minus 5 is 7 with a borrow. Right? Okay. So how long did it take you to remember all these rules? Which number subtract which number has which borrow? Was it easy? It's not that easy, right? Because 1 minus 5, for instance, is -4, but in terms of a number with a borrow, it is 6 with a borrow. Okay? Same thing with addition. If I ask you what is 4 plus 8, it is 2 with a carry. Okay? How long did it take you to remember all of these little rules for addition and also for subtraction? It took you a little bit of time, okay? Because there are quite a few cases in base 10 that triggers a borrow or a carry. Is that okay? What about binary numbers? Think about base 10 numbers, okay? Base 10 numbers, you have 0 minus 1 is a 9 with a borrow. 0 minus 2 is 8 with a borrow. 0 minus 3 is 7 with a borrow. Okay? There are many, many cases that you actually have to memorize in your head in order to deal with your subtraction in base 10. In base 2, how many combinations can we have? 4 combinations. So in base 2, okay, I'll just kind of write it out here. So in base 2, it is so much easier because there are only 4 cases. We have the usual easy ones. So let's deal with the 3 really easy cases first. Do you guys want to start with subtraction first or addition first? It doesn't matter to me.
Let's do addition first.
Okay, let's do addition first. So in base 2, there are 3 easy cases of addition and 1 kind of tricky one, but not really too tricky. 0 plus 0 is what?
0.
In base 2. But this is base 2. Well, it doesn't matter what base it is. 0 is always 0. Okay, so 0 plus 0 is 0 in base 2. What about 0 plus 1? 1, okay. What about 1 plus 0? 1. So the only one that is kind of tricky is 1 plus 1, right?
1, 0.
Well, it's 1, 0, but if I want to express it as a number with either a carry or a borrow, what would it be? 0 with a carry. So I'm going to say, with a carry is carry equals to 1. Because this way I can kind of standardize the other one, because this one is simply means, it has a carry of 0, and a carry of 0. That's it for binary addition. 4 rules, you're done. Okay? Really? So let's go ahead and see if I can deal with some multi-digit addition in base 2. But before we do it in base 2, let's kind of remember how we do addition in base 10. Okay? I know most of you are kind of frown, go like, oh really? In a class like this, we have to do multi-digit addition in base 10? Yes. But just to make sure that we all remember how to do stuff like that. I mean, cannot take these things for granted. All right, so let's go ahead and work this out. What would be that digit? It's 3 with a carry. So combined with a carry, what is this? 7 plus 4 is 1 with a carry. And since I have another carry from the one before, this becomes a 2, right? And then this one is 2 plus 9, which is 1 with a carry. But since I have another carry from before, it becomes a 2. And since this digit is implicitly 0, 0 plus 0 is 0. But since I have a carry from the other digit, it becomes a 1. Is that making sense? Okay. How many people did this without even having to do it digit by digit? You just kind of look at it, you eyeball it, and you came up with the answer. Some people can do that. All right, I cannot. Okay, let's try it with binary numbers this time. So we have, let's say 1, 0, 1, 1 in base 2 plus, I don't know. Let's say 0, 1, 1, 0 in base 2. All right. So I can do it in one way or another, but I can do it without an explicit row of carries, because this may be easier. Okay, so what is this one? 1 plus 0 is 1. Okay, what about this one?
0 with the carry.
It's a 0 with a carry. And what about this one? It becomes a 0 because there's an implicit carry from the previous one. And what about this one?
Same.
0. And what about this one?
4.
That's it. Okay? So the rules of addition is so much easier in binary, okay? Because you only get 4 possible cases. Are there any questions about binary addition? Okay, now we will come back to binary addition a little bit later and look at this from a slightly different perspective. We are almost running out of time, but I am going to give you the 4 rules of subtraction in binary first. Okay, just so that you know, okay, so that's pretty easy too. Okay, in base 2, we have 4 cases in subtraction 2. We'll deal with the easier one first. Okay, 1 minus 1 is 0. And do we have a borrow in this case? So I would say borrow is 0. The borrow is 0. What about 1 minus 0?
1.
Is a 1 with a borrow of 0. Okay, very good. I will have this one. I'll deal with all the easy cases first. 0 minus 0 is 0 with a borrow of 0. So this is the only one that is tricky. 0 minus 1. What is that? 1 with a borrow. That's it. So these are the 4 rules for binary subtraction. The cases for base 10 is a lot harder. Because remember, in base 10, you have 10 possible numbers for this column, and then 10 possible values for each of those on the other column. So potentially it's a 100 case type of scenario, even though many of those are easy. But you really have 100 items in that table. It's a 10 by 10 table. In binary, it is a 2 by 2 table, 3 of which are completely easy, and only 1 is kind of like, let me think about it a little bit. Yep, that makes sense. Okay, so I'm going to stop here because we are running out of time. But I will give you a preview of what we'll be talking about on next Tuesday. I will give you some examples of, I will revisit binary addition first, just to refresh your memory. And then we'll do some binary subtraction. And then we'll do something that is kind of funky, which is looking at addition and subtraction not as arithmetic operations, which is like adding and subtracting and stuff like that. We'll look at it from the logical perspective. Can we replace addition and subtraction with logical operators like and, or, and not? Because inside the computer, it doesn't really know how to add or subtract. But guess what the computer is really good at? And, or, and not. Okay? So eventually we have to translate everything to and, or, not. So next Tuesday, we'll do that with binary addition and binary subtraction. Okay? I'll be going to room 128, so if you want to get the homework assignment knocked out in a few minutes, go ahead, I'll be there, and that's the end of today's lecture.